Game on. All right, so dividing fractions. We did talk about this a little while ago. If Mrs. K, because you know Mrs. Kingston's a big footy fan, loves her footy almost as much as she loves Radiohead. If she plays 3 games of footy, she has played how many quarters of football? Jacob.
12.
Are you sure?
Incorrect. Yes.
It is.
If she played 4 games of, 3 games of footy and it's 4 quarters, it's just 4 times 3, which equals 12.
Yeah, so you've solved that problem by actually doing a multiplication, but strictly speaking, we should be doing this as a division. So what we're doing is we're taking 3 games of football and dividing it into quarters and getting 12. Okay, and your instinct is right though, Jacob, and that's exactly what we're after. It sometimes tricks people because if I had asked that question differently, if I said, what is 3 divided by a quarter, most people, or a lot of people, would actually say the answer is 3 quarters. All right, but because I asked it the way I did, most of you already knew that meant 12 quarters. There's a few steps that we need to follow, but we're going to have a bit of a crack at this. All right. First off, we need a problem that we can deal with. So let's go with. Okay, I've got black. Let's go with 4 divided by 1/5. We'll keep it nice and simple to start with. What's the first step that we actually have to do here? Yep.
Convert 4 into a fraction, so 4 over 1.
Yeah, we do. It's actually we can leave it as a whole number, or we could write it as 4 over 1. So the first fraction stays the same, and sometimes it actually will look more like a fraction. So the first one stays the same. What's the next thing we have to do when we're trying to solve a problem like this? Any ideas?
Oh, you convert it? Yeah.
So you're close.
Well, I know how to do it, but I can't really...
It's a tough one to explain. It actually goes back to the way Jacob solved the last problem. Instead of thinking of it like a division, he switched it around and thought of it like a multiplication. So the second thing we do is change the divide sign to a times sign. That is the next thing we do. So I'm going to write that just here. But we can't just go changing things willy-nilly. If we change that, we have to change something else to make sure that this actually gets us where we want to go. We need to flip the second fraction that upside down. Okay, so the original fraction was 1 over 5. What's it going to look like if I turn it upside down? 1 over 5, flip it, what have I got?
5 over 1.
5 over 1, yeah. So 5 over 1. In this case, that actually looks to us like an improper fraction, but that's okay. Now, we already know how to do multiplication of fractions. We've been doing that a bit. We simplify if we can. Now, can I actually simplify anything here? Not really. So then I go straight ahead and I multiply my numerators together. 4 times 5 is...
20.
I've sort of run it... no, I can put it here. Equals 20 and... Oh, what's my denominator? 1. That's the end, isn't it? That's it. We're done. So 4 times 5 is 20. So 4 divided by 1/5 is equal to 20. Now, who already knew that before we went through and solved that problem? Good. And that's because it was such a similar question to the previous one that was 3 divided by a quarter. Let's try one more. And I'm going to make this a little bit uglier. Let's go for Let's start off with an ugly number. Like, let's have 3/4. And we're going to divide it by 2/3. I'm guessing not too many of you can do that one in your head straight away.
I know how to do it. So, when you divide fractions, you make a line below.
Now, just remember, we actually talked about 3 steps. What's the first step?
The first fraction stays the same.
The first fraction stays the same. Good. All right. What's the second step?
You flip the second one,
No, it's not the second step.
or you change it to a times,
Good.
and then you flip it from a 3 is at the top and a 2 is at the bottom.
Are we happy with that? Those 3 steps. First one stays the same. Divide turns into a time sign. Second fraction gets flipped upside down on its head. Done. And now we've got a multiplication question that we can solve. Hey, is there anything there we can simplify?
No.
I can't see anything, so... Oh, I should have started with an equal sign there. That was a bit naughty. All right, so moving down the page. 3 times 3 is
9.
9.
over. 4 times 2,
8
8.
8. And we're done.
We have
Our
to
work
change
here is...
to,
makes numerals.
You're right. We can simplify that, so we should.
1.
Which equals, what do you got, Leka?
1 and 1 over 8.
Beautiful. Should we do one more?
Okay.
Last one. Last one. Let's go for... All right, start throwing football players' names at me, please. Go.
Luke Shuey.
Luke Shuey and
Now,
Nat Fife. Okay, so we're going to go for Luke Shuey divided by Nat Fife.
Luke Shuey's number 13.
Oh, he is too. I was thinking Elliot Yo. All right, I'm going to go with that anyway. I need another football player then. Okay, we're going to divide it by Nick Natanui fractions of Luke Shuey. All right. You can do that, right? All right. What's step 1?
keep the first one the same.
First one stays the same. Tick.
Flip the divide to a times.
Good. The divide turns into a time sign. Tick. And step number 3.
Swap the numerator and the numerator.
Yeah, the second fraction gets flipped upside down. Tick. All right, now we've got a multiplication problem. Can we simplify anything?
Yes.
Actually, we can, can't we, Mate?
So the 6 and the 3 both go into 3.
Yep.
Yeah, the 6 and the 9 go into 3.
Good. So 3 into 9 goes
3.
3 times. 3 into 6,
2.
2. All right. Oh, I forgot my equal sign there again.
Naughty, naughty.
Lucky I'm not recording this or anything.
Yes, you are.
All right, multiply the numerators. 2 times 13 is... Come on.
2 times 13. 26.
26, thanks. And 7 times 3 is...
21.
21. Okay, and we're done here.
No,
No.
Why not?
we need to change into a mix.
Yep, so, mixed number fraction. Who's got it for me? Leka got it for me last time. Take it away, Austin.
So it's 1 whole
Yep,
and 5 over 21.
very good. Okay, easy?
Yeah.
Easy peasy?
Yeah.
All right. Should we do one of the mega tricky ones now or not? No, we'll fall off that bridge when we get to it. All right, I'm going to stop this for now.